Hey, it's Mr. Kingsbury. These shouldn't take too long. Just mostly some examples, but I wanted to give you some background on what's called the sum and difference of two cubes. Of course, we're in our factoring unit. This is actually the last set of notes for the factoring unit here in Algebra 2. Don't forget to put your period and the date. And our essential question today is, how do I factor the sum or difference of two cubes? And it's actually pretty formulaic. In fact, I'll give you those formulas in just a second. To begin with, though, where does this come from? Well, like a lot of things in math, someone found a pattern and realized that we could use that pattern to factor some stuff pretty quick. So what is that pattern? Well, it looks like this. First, you're given a perfect cube and another perfect cube. And so, like, this one is the sum of the two cubes. So if you're given a cubed plus b cubed, you can factor that into two polynomials, a plus b times a squared minus ab plus b squared. And for the difference, you would be given a cubed minus b cubed, and that would factor to a minus b times a squared plus ab plus b squared. And as I do the examples, you'll see that it's really the same thing over and over and over again. All I'm really going to do is take the information that I've been given, and I'm going to get these other things. So you'll notice that what we need is an a and an a squared, a b and a b squared, and an ab. We'll be given a cubed and b cubed. So we can take that, get the information we need from it, so on and so forth. It's kind of cool. Just a side note, to find cube root in your calculator, you would hit math and then option 4. And then you type in your number and you enter. Just FYI, in the classroom, I have a list of perfect cubes that you can use if you want. You don't have to, whatever. But just in case, I thought I'd give you that little extra piece of information there. So let's just do some examples, and yeah, we'll be done. So let's start with this one. We'll do x cubed plus 125. So what I'm going to do first is identify my a cubed. That's going to be the solution. By the way, because of the plus, I'm going to use the sum formula. So this is what I've been given, which means the first part is my a cubed, the second part is my b cubed. This is my a cubed. Now what I'm going to do next then is take the cube root of both sides. The cube root of a cubed is a, the cube root of x cubed is x. And then I'm going to square both sides. A to the second power is a squared, x to the second power is x squared. Now I'm going to do the same thing with b cubed over here. Now my b cubed is my number, 125. When I cube root that, the cube root of b cubed is b, the cube root of 125 is 5. Then I will square both sides. So b to the second power is b squared, 5 squared is 25. And the last thing I need to find is a times b. Well, I have an a here and a b here. My a is x, my b is 5. X times 5 is 5x. So why did I do all that? Well, that's to find the bits and pieces that I need. In order to factor this, I can follow this rule here, or this formula. It says I need to know what a and b and a squared and ab and b squared are. Well, I have all of those now. And in fact, the way that I've set it up, this is your binomial and this is your trinomial. So you can write x and 5, and then x squared, 5x, and 25. And I know what you're saying right now. You're saying, Kingsbury, looks a little funky. We don't have any signs. You're right. And here's how the signs go. The sign of the binomial is always what you're given. This is a plus, so I'm going to put plus. The next sign, the first one of the trinomial, is always the opposite of that. So what you're given, the opposite of that, and then the last sign is always a plus. So when I factor it, it looks like that. Let me get you a couple more examples here so you can get a real good feel for this. We'll do some more examples in class, so I'm not going to get too in-depth with some of the more interesting things you could see. I just want to give you some examples real quick. So how about x cubed minus 216? So my a cubed would be x cubed. A will be x, and when I square both of those, a squared equals x squared. My b cubed is 216. Now what happens here is people want to put negative 216. You don't have to do that. Because we're using a formula up here, the formula has already taken that into account. So all you have to do is use the number part, which makes your life a lot easier, I think. B is going to be the cube root of 216, which is 6. And then b squared will be whatever 6 squared is, which is 36. Lastly, I need my AB. That would be x times 6 is 6x. So I have x and 6. That's my binomial. My trinomial is x squared, 6x, and 36. I was given a minus, so I'll put a minus here. And then the opposite of that is a plus. So minus, then plus, and the last one is always plus. It's the same thing every single time. So let me just do a couple more examples for you so that you can see where this kind of leads. And then, then I'll leave you on your way there, I guess. So example 3 here. Now I'm going to take it up a notch. I like to make things a little more difficult. You're not going to get just problems like what you saw here. But let's add a little more difficulty. Not much, though, I promise. Let's say I give you, 27x cubed minus 343. I'm not going to change anything about the way that I do this. I realize now, though, that this is different because there's a number in front of the x cubed. A lot of people, they get thrown off by that. They're not sure. They think they have to handle it differently. You don't. I'm going to do exactly the same thing. My a cubed is this first term, 27x cubed. I'm still going to cube root both sides. The cube root of a cubed is a. I'm going to take this in parts. The cube root of 27 is 3. The cube root of x cubed is still x. That hasn't changed. And then I will square both. A squared is, a squared. 3 squared is 9, and x to the second power is x squared. My process hasn't changed. All that's changed is that I have another little piece to think about. That's it. Then we got b cubed. That's going to be 343. I'm going to cube root both of those, so I get b equals, the cube root of 343, by the way, is 7. So b equals 7. Then I will square both sides. B squared equals 49. And last but not least, what is AB? Well, that will be 3x times 7. 3 times 7 is 21. So 3x times 7 is 21x. So what's my answer? 3x and 7 in the binomial. The trinomial will be 9x squared, 21x, and 49. I was given a minus, so I'll put a minus here. The opposite of that would be a plus, so I'll put a plus here. And then I always put a plus on the end. And I know what you're thinking right now. You're thinking, is there any way this could get more difficult? A little bit, not too much. I'm not going to kill you with it, but I'm going to do one more, and I'm going to add one more extra thing. So last example. Here we go. Let me think really quick. Okay, so let's say that I gave you let's do 27 x cubed plus 216. Now both of these are perfect cubes. I think I may have messed that up. Sorry. Yeah, I did, didn't I? Yeah, that didn't work the way that I wanted it to. Sorry. Okay, I'm gonna have to try something else. I thought I was being all kinds of cool and crafty, and I was not. So let's do this. How about 40x cubed and plus 320? What you may notice is these are not perfect cubes, and that's, I guess, where I messed up. Although there is a way to do what I just did with perfect cubes. That adds another level of difficulty. Anyway, these are not perfect cubes. So immediately you might go, problems, Kingsbury. Yeah, we can't jump right into factoring the sum and difference of cubes. But what we're supposed to be doing every time we factor is factoring out the greatest common factor first. And I haven't had you do that yet. I didn't have you do it on the first 3 examples because I wanted you just to see the process by itself. But now that you've seen it 3 times, we can do that on this last one. So my question to you would be, what is the greatest common factor of 40x cubed and 320? And I think it's 5. No. Wow, I didn't do this well at all. It's more than 5. I was going to say 5, and then I realized they both end in 0, so that would be 10. And then I realized that if you factor out a 10, you get 4 and 32. Yeah, I didn't think about this well, so I'm going to change this number again. I didn't want it to be quite like that. Wow. This is what happens when you do things on the fly, I guess. Let's try this instead. Okay, let's do 135. What I wanted it to be was 5. That's where I was going, just keeping it simple. So when you factor out a 5, 40x cubed divided by 5 is 8x cubed. Then 135 divided by 5 is 27. And now we can use what's in the parentheses and go through our whole process, and life is good. So a cubed equals 8x cubed. A will be 2x. I cube rooted both of those. And then a squared will be 4x squared. B cubed will be 27. B will be 3, which makes b squared 9. AB will be 2x times 3. 2 times 3 is 6, so 2x times 3 is 6x. And this gives me 2x and 3, 4x squared, 6x, and 9. I was given a plus, so that's what goes here. The opposite of that goes here, and a plus goes on the end. Now, I do have students that get this far, and they don't get the problem correct because it's incomplete. Not that anything is wrong, but they'll give me this, and I can't give them full credit because it's not that it's wrong or that anything's been done wrong, but we factored out a 5, so don't forget that, okay? And that's the sum and difference of cubes. We'll do a few more examples in class. I will also post them on the Google Classroom. I will see you later.